Today we are going to discuss another interesting, tricky topic, charge flow and electric potential. In order to discuss this, we will consider a sphere with radius capital R, which is enclosing a concentric sphere of radius small r, which has got charges plus small q residing on the surface of the inner sphere, and at the same time we have got charges plus capital Q residing on the surface of the outer sphere. So throughout, I'm not writing all the Q's and all the small Q's, but you can understand that we have got the sphere with radius r, which has got charges Q residing on its surface and charge plus small q residing on the surface of the sphere, which has got smaller radius. Now, to explain the potential, we have learned the potential because of charge on a surface is nothing but the amount of work done in bringing a unit positive charge from a point at infinity to a point of consideration against speed, and we have derived an expression for that as we will write for V capital R is equal to 1 by 4 pi epsilon naught, and we have got Q divided by capital R plus, because if you have got potential because of the charges that are residing on the outer surface, we have got Q by R, and we have got potential because of the charges that are residing on the outer surface of the concentric sphere, which is nothing but again 1 by 4 pi epsilon naught into small q by capital R, because we are considering only the largest sphere. And remember, the potential at any point, including the surface of the sphere, inside the surface of the sphere, including the surface of the sphere, will be the same for any surface. For example, if I'm talking about this sphere, the potential right from the surface to the midpoint will be the same at all points inside space. So we have got 1 by 4 pi epsilon naught into q by r plus 1 by 4 pi epsilon naught into small q by again capital R, because r is the radius of the external sphere. Now next, for the smaller sphere, V small r is equal to, I write 1 by 4 pi epsilon naught into, we know it's q by small r plus 1 by 4 pi epsilon naught into, because of the external charge, q by, remember it's capital R. This is a bit slight confusing. Let me explain to you the point, because the charge that is residing on the surface of a particular sphere will create the same potential at any point beginning from the surface to the midpoint of the sphere. So we've got two equations generated. So clearly it is evident. Now this part and this part, they remain the same. But whereas if you look closely at this part and this part, we have got small r is having a lesser value than the big R. So obviously this part of the fraction will have a greater value all in overall compared to this value. So if you ask the net potential, I will have to do it like this: VR minus VR, the effective potential, is equal to, let me write the equation, 1 by 4 pi epsilon naught into q by r plus 1 by 4 pi epsilon naught into capital Q by r minus 1 by 4 pi epsilon naught into capital Q by capital R minus of 1 by 4 pi epsilon naught into small q by capital R. So what happens, this part and this part is cancels, will get cancelled off, and what is remaining will be 1 by 4 pi epsilon naught into q by r minus q by capital R. So now the flow of charges, once you connect these two spheres with a wire, as long as the positive charges reside on the surface of the inner sphere, charges would definitely flow from the inner sphere to the outer sphere, owing to looking at this equation. So but if the polarity of the charges that are residing on the inner sphere changes, then the flow would be a different scenario. But as such, here, as far as q is concerned, if it is positive, the flow of charge, the potential, since the inner sphere has got larger potential compared to the external sphere, you should know that potential will always ensure that the flow is from region of high potential to the low potential. So the flow of charges would be from the smaller sphere to the larger sphere. Therefore, we have got VR minus VR as the resultant potential, which is expressed by this equation.